Thank you everyone for joining this webinar. I hope you find it useful. The topics we're going to cover are mostly Term 1 technical maths topics for grade 10, 11 and 12 with some added bonuses thrown in like calculus and complex numbers and just the standard stuff, just to give you an idea of how things work. So this calculator that we're working with is the ELW506T. It is upgraded, and so you'll see I've got actually two calculators. So this is the upgraded version. It's just got a lot more functions than this. Well, it's got about 100 extra functions, and it looks prettier. And the simulator is much prettier too. So that's the difference between the two. But everything this one does, this one will do even better, and this one does more things than the other one. So this one includes a table mode as well. Okay, so just some quick basics. You can turn your calculator on using this button. Your orange second function button activates your orange functions. Your teal alpha button activates your teal functions. Fakile says differential calculus. Thanks, Fakile. Then you've got mode, which allows you to access all 9 of the different modes on this calculator. Underneath that is BS or backspace. And then, of course, change just changes the way your answer looks from a surd notation or fraction notation through to a decimal. And then, of course, your equals button, which will help you lots as we go through this. Well, I see there's one more here. And Bismarck says integration. Fantastic. So there are 9 different modes. Normal does things like fractions, integers, probability, trig, all of that fun stuff. I will show you a shortcut for class parts, which is awesome. Your stat does all your basic statistics that you require. We're not going to do stats today because, as far as I'm aware, correct me if I'm wrong, Claire, but single data and linear regression are not part of the technical math syllabus. So, and then, of course, the table function, which I will show you how to use for calculus and teaching finance and factorizing. Also, finance is not in today's. I could be wrong. Sorry, guys. My child woke me up like 4 times last night. And I have recorded that for all possibility. And then, of course, the complex numbers, which we'll go through, the equation solver, which we'll go through as well. And then further down, your matrices, which we don't cover in technical maths. And in fact, none of these are covered in technical maths, so we don't need to worry about this. So this one is just the older grandpa version of that one. And all of the similar functionality, just in slightly different places, but for the most part, very similar. All right, so a new function that we've added just to the ELW506T is the prime factorization function. And it's really handy. I'm sure you've seen it before on other calculators as well. So I'm not going to do it here physically because I want to move on to this new function, which is the highest common factor function. Sorry, I was busy creating worksheets. Sorry, the webinars for tomorrow for Mathlib, so that's fine. Everything is funny here. I just want to change my notation back to the way it was. Okay, so you'll just see I've got a comma set up here, and that's just you can just choose your comma and your decimal point. That's at number 6. You can just choose what you like. So if you prefer the dot, you can use the dot. If you prefer the comma, you can use the comma. It's up to you. It's whatever you're comfortable with. It will just change how your answers are displayed. It doesn't change your when you put decimals in at the top there though. Okay, so back to the highest common factor. If I'm looking for the highest common factor of 54 and 72, then I can say 54 second function and 2 will give me GCD. GCD means greatest common divisor, which is exactly the same thing as highest common factor. 72 and equals, and my highest common factor 54 and 72 is 18. And of course I can also add more numbers as we go, so that's a really handy one as well. And you can add as many numbers as you like to this row. You can see it's just changed now because I didn't use the same thing. If I put in 180 maybe. It's very lazy, but yes. Okay, so you can see the difference. And then of course for LCM it works exactly the same way. So if I have 54 and 72, there's my LCM. And this is particularly nice for teaching your fractions before you dive into the algebraic fractions as well. All right, so those are the two cool new functions. Then from there, I'd like to show you this really awesome function, which allows you to do your class marks in a very quick way. So say, for example, you've now set a test which is out of 70, and you want to convert all of those marks to something out of 100. So at the top of your fraction, you put whatever you are converting to, which is 100. And at the bottom, you put the total that your test is out of, which is 70. And then you say times, and you put your first student's mark. So let's say that mark is 40. And we say equals, and we get 57 and 1/7, or basically 57%. Now, for your next student who got 55 out of 70, all you would do is type in their mark. So 55 and equals, and we get 78, 79%. Okay. So that's a really nice mechanism. And again, you can go for as many marks as you require on the calculator. It won't change that. Okay, great. So that's a nice thing. If you have teachers who don't have the scientific sharp calculator, but they have a basic model, it works exactly the same way. So if they have any standard sharp calculator, what you would do is say 100 divided by total test mark equals times the first student's mark equals, and then you would just keep saying mark equals mark equals mark equals until they have finished their class list. So that's a really nice trick, very nice to know as we enter the new year and we want to change everything around. So the next thing that I want to show you is just how to set up your recurring decimals, because I see that is part of your first 2 or 3 weeks with your grade 10s. Okay, so say for example we have 5. Let's change it. Let's make it 55 divided by 9. That's just a very basic recurring decimal. And you can see it's 6.11111. Okay. What we can do is go to second function and setup, where we looked at the decimal points, and we'll see at number 5 it says recurring decimal. So we can change our recurring decimal and turn it on. And so when we press change now, you'll see that it gives it to me in a recurring decimal format first, and then as a recurring, just the normal decimal notation. Now, the question we got asked yesterday was, can we input a recurring number and get the fraction for it? And the answer is yes, of course you can. So what you can do is, say for example, we just have a 0.222, just as a very basic example. So all you would do is just put in a whole bunch of 2's, press equals, and there's your decimal, your fraction, your recurring fraction. Now you can also do a pattern. So you've just got to repeat the pattern a number of times in order for the calculator to pick it up. So my rule of thumb is normally when you see that arrow, you should be okay. And there you go, it's picked it up beautifully for you now as well. Okay, so that's just the recurring decimals side of things and for your grade 10 students. Okay. Now, the other thing we get asked often is, can we change the display of the calculator to not give us a fraction as an answer first, but to give us the decimal first? And again, yes, you can. So what you do is say second function and math. And this time we're going to look at editor. So we're going to press 2. Now you have 2 options, right view and line. So look, line is from days gone by when we used to write fractions in the R format. If that makes you happy and you're yearning, you have a nostalgic yearning, then absolutely please press 1. But otherwise, just press 0 for right view. And what we're going to do is, instead of using the exact, which is the answers that we have been getting so far with the fraction and the surds, we're just going to ask for an approximate answer. So if I have 3 times 2.58, what it will give me is a decimal answer. And then if I press change, it will take it back to a fraction answer for me. So you can have both answers. It will just choose to show you the fraction, the decimal answer first. It's particularly nice for when your students are doing counting and they're struggling with that answer and they're rounding decimals and doing numbers and all of that sort of stuff. I'm going to change it back because otherwise the rest of my examples are going to look very strange to you. So that's, let me just show you again. Second function, math, that will give us access to the setup button. 2 for editor, 0 for right view, 0 for exact. Okay. All right. As you can see is on the slides, what I've done is added both calculators if they can do this. And in fact, I'm wrong. This calculator should not be on that slide. Right, so the next thing that we want to look at is teaching exponents. And there's a really nice way to do that using this calculator. So if we say 2 to the power of 3 times 2 to the power of 4, and we press equals, we get 128. Now we can show the students step by step. So we can again say 2 to the power of 3 plus 4 gives us 128. And we can also say 2 to the power of 7 gives us 128. What we could also do is go back up here and say second function, before I do that, first press your equals button, then say second function and your exponent, which says p fact, and then it will give you the prime factors. So 2 to the power of 3 times 2 to the power of 4 is 2 to the 7. How did we get 7? We said 3 plus 4. So it's just a nice way to show them where that rule is coming from. As long as I have the same base and I'm multiplying, I add the exponents. And you can do it with the other rules as well. You can also do it with surds. So if I have square root 2 and I have times square root 3, it's going to give me square root 6. And this is exactly the same as saying square root of 2 times 3, which will give me square root 6. So it's just a nice way to prove these rules. I know students often question us and they think we're making up stuff. So this is just a nice way to show them where the rules come from and so on. Now we do logs in technical maths. So I want to show you the 2 ways that you can do a log. The first is to use your base 10 log. So you don't need to write the base 10, you just press log and of course type in your value and press equals and it will give you your answer. Your other option is when you have a log with a different base other than 10, then you would say second function and your pi button, and you'll see now you can fill in your base and you can fill in your number and we can say equals and it will give us the log. So those are just the 2. And of course, again, proving log rules to students. Sorry, that should be a plus. And let's say 16. So here we're going to get 3. Here we're going to get 4. So our answer should be 7. Right? And it's exactly the same as saying 8 times 16, which we can do as well. So we can say second function base 2, 8 times 16. And that will also give us 7. Again, you can prove this log rule to your students using that same mechanism as well. Okay. Are we happy? Any questions before I move on? If you're happy and you're still awake, just give me a wave of your hand or raise your hand. Yay, awesome, fantastic. Thanks, Willem. I just saw you know, Ijaba. Thanks, Timothy. Awesome, fantastic. So the next thing that we want to look at is your binary conversions. And both calculators are really very, very easy to do binary on. So say, for example, we want to convert 258 into a binary number. I see a question. Let me just pause here before I go. Oh, fantastic. Thanks, Marta. And another one that says, oh, Lungule says she's happy. Fantastic. Okay. So we have this decimal number and we want to convert it into a binary number. So what we can do is say second function, and over here on your divide button in orange, it says to binary. And if we just press that, it changes our number into a binary number. Now, I see that you need to be able to add in binary, so we can add in binary. We can multiply in binary. We can divide in binary. So you can see it's really quite a nice function here on the calculator as well. That doesn't look like it should be binary, hey? Once you are done, you can, of course, also convert between binary and decimal. So we could say, okay, I want to know what the decimal value of this binary number is, and I can just say second function, and I go back to decimal. That's on my equals button, and I can see that that number in binary 10111100 is actually 92 in decimal notation. So the binary on the calculator is very, very easy to use, and you don't need to go anywhere. It just stays in normal mode the entire time. So you can switch between various calculations all the time. The other nice thing in technical maths is when you start doing conversions and constants. Okay, so if, for example, I have a conversion and I want to convert between ounces and grams, what I'm going to do is, let's say I have 23 ounces and I want to know how many grams that is. I'm going to press alpha. I see my slide is wrong. I need to change it. Alpha and 5 for convert. And then you'll see you have a whole list of conversions, and you actually have 44 different conversions that you can use. So we're going to go and look through where it says ounces to grams, which is 13. You're going to press 13, and we're going to say equals, and I now get 652 grams. So 23 ounces is 652 grams. All right, cool. Before I continue, let me just continue with this train of thought. You also have 52 different scientific constants. So if you have students who are doing technical science, all of the scientific constants are here. And if you want to just use one, I'm just picking one at random. Must be honest with you, I have no idea what those symbols mean. It will just put that constant value in for you. So when you're doing a calculation, you can just go and find the constant instead of having to type that whole long thing into your calculator. I see I have a question here. So Lawrence, the question from Lawrence is, won't the learners lose marks for not showing calculations on binary? Lawrence, the whole point of, yes, Chantal, the older version of the calculator can do conversions. So the whole point of having a calculator is to check your work. It's not to do everything for you. And when we're in high school, we're learning the methodology and the theory. And the whole point of that is to learn how to solve problems. And we were saying this yesterday in the math session as well, is a calculator is a wonderful tool, and it's a fantastic tool for teaching kids how to do various things. And when we go and look at the calculus, I'll show you my points explicitly, because it just shows you an intuitive understanding of the graph versus just spouting this knowledge. So yes, they will lose marks for not showing calculations, but I am not a technical maths expert as such. So I would leave that to maybe Lichle. I don't know if you're here, if you could answer that. I think you're a tech expert, or Inchi, if you're online. Both of them are technical maths facilitators, and they might be able to answer that question for you, Lawrence. So let's just leave that to the judges. But to my understanding is, yeah, rather use it to check your answers, because that's the important thing, and make sure that you're on the right track. And you can do step by step as well. So it's really up to you how you use it for your students. Alrighty, so from here, let's talk degrees, radians, and gradients, and time. So the other nice conversion is also the degrees, radians, and gradients conversion. So if, for example, I have 30 degrees and I want to convert it into radians, I can say second function, and I'm just going to use the shortcut here on my decimal point. It says DRG arrow. So it just converts rollingly across degrees, radians, and gradients. So now your calculator is set to radians. If, for example, I have pi over 4 radians and I want to know how many degrees that is, I can say second function drg will give me gradients. And again, second function drg will give me 45 degrees. So pi over 4 is 45 degrees, which makes sense because 2 pi is 360. So we should be able to work it both ways. But again, it is very nice for checking your answers as well. Now, if you want to do the shorter version of that, what you can actually do is store that function into your D1 key. So I can say like so. And then when I press, let's say I have 90 degrees now and I want to know radians, I can just press D1. So it's just a shorter version. Instead of having to press second function the whole time, you can now just press your D key. And the nice thing about your D keys here is that you can save functions over them. So it's any function that's already on the calculator. You cannot save a formula. It's mostly for those functions that require 2 or more buttons. And it's just a way to be lazy or to save yourself time when you're doing a lot of the same calculation over and over again. From degrees and radians, we want to move into time. So with a time calculation, there are 3 different examples that we can do today. The first is, if I have so many minutes, how many hours do I have? So I can do that by saying 0 hours. And let's say we have 470 minutes. So like so. And I can just press equals. It will give me 7 hours and 50 minutes. And then I can say second function DMS, and that gives me 7 5/6 of an hour. So that's one calculation. The second one is if I am traveling 500 kilometers and I do an average speed of 114 k's, how long does it take me to get somewhere? So we can say 500 divided by 114 gives me 4 hours and 20 to 25 minutes, somewhere about there. We can change the way that this answer looks by pressing second function and your DMS button, and it will now convert it into sexagesimal notation. So 4 hours, 23 minutes, and 9.457 seconds. Okay. The last version of this that you can do is the how long did it take me to do something. So if, for example, I started working at 9:45 and I stopped at 12:30, how many hours of work did I do? So I'm going to say 12:30 minus 9:45 is equal to 2 hours and 45 minutes. And again, I can say second function DMS, and it will give it to me in just hour notation. Sorry, guys, they are mowing the lawn right outside my window. Just give me a sec. You know, when you plan webinars, every loud noise that can possibly happen on the planet of the Earth will happen right outside your window. But we love you guys. Thank you for being patient. Okay, so those are the 4 different time versions that we can look at doing and the various calculations. Now, I will send you this presentation in PDF format so that you can see and use these as you go through the syllabus with your students. It's great to have this all thrown at you for an hour-long session, but when you actually get to using it with your students, it's always nice to have something to refer back to. Okay, so the next thing that I want to show you is how to find factor pairs of a number. And I know factorizing for lots of kids is just a drama, okay, and they often don't grasp the concept. So I want to show you a really nice way to teach it and hopefully to help them improve. So the first step in teaching factorizing is making sure that the kids know how to find factor pairs. And of course, if they knew their times tables and their division, which you can practice using the mental maths function on the calculator, this wouldn't be such an issue, but they don't know it. So that's why we use the shortcut. Okay, so I'm looking for factors of 36. And what I do is I divide it by x. So essentially, it's actually a hyperbola with a very high a value. And I'm just going to say equals and equals equals. I'm just going to leave start and step as they are. So here we'll see anything divided by 0 is undefined. That's asymptote. And we can go from there. Now we can look. 1 and 36 are a set of factors. 2 and 18, 3 times 12, 4 and 9. 5 is not a factor because it has a decimal answer, so I ignore it. 6 and 6. So I have found all my factor pairs because I can see now my 7 and my 5 have switched. So I know I'm all done and I have got everything I need. Now, from here, we can move on to teaching factorizing. Okay, so we have the basic skills to find the factor pairs. We have them in columns for ourselves. And so what we're going to do now is I want to show you a really nice way to teach these. Okay, so we have a sign. What I do is I always look at the sign at the back. If the sign at the back is a plus, it means the signs in my brackets are exactly the same. And I know which sign to use by looking at this sign over here. So it's going to be a plus, and this one over here is going to be a plus. I see a question. Okay, Musa, I'm going to do the example of the factor pairs again right now. So just give me a sec. So what I'm going to do now is I'm going to go to my calculator and I'm going to find all the factor pairs of my C value, which is in this example, very basic, a 6. So I'm looking for factor pairs of 6. So I press 6. Then I press my fraction button and I press my RCL button twice, like so. Okay, and I say equals, and I'm going to ignore function 2 because it's not important right now, and I'm going to leave those values as they are. So here are my factor pairs. I've got 1 and 6 and 2 and 3, and if I go down, I've got 3 and 2. So basically I'm just looking at these first 2 sets. Now we want to know what adds up to give us 5x. We're looking for our b, and because the sign at the back is a plus, I know that I must add my 2 columns together. So I have plus 1 plus 6 gives me plus 7, which is not my middle term, so I move on to the next one. Now I have plus 2 plus 3 gives me plus 5. That is my middle term. So now what I know is that here my factors are x plus 2 and x plus 3. And again, we can see the same thing. My sign at the back is a plus. So I need to add my 2 columns together. I'm just going to write them here. You saw them on the calculator, right? So my sign at the back is a plus, which means I have same signs. And I am adding my 2 columns together to get my middle sign. And my sign in the bracket is a minus, because that's that sign over there. Okay, so minus 1 minus 6, or plus 1 plus 6 gives me 7, and that's not what I'm looking for. 2 plus 3 gives me 5, and that is the number that I'm looking for. And then, of course, I just add my negatives. So it's going to be negative 2 and negative 3. Now, for the negative 6, it works slightly different. So here are my 2 factor pairs again. Right, so in your columns, here's my x column and my answer or y column. Okay, so here in my 6, I have a negative, which means my signs in the brackets are going to be different. And that means my signs on my columns are also going to be different. So I'm going to pull this column plus and this column minus. So here I have plus 1 minus 6 gives me minus 5. That is not my middle term, so I can ignore those. My next one is plus 2 minus 3, which gives me minus 1, which is my middle term. So I have my factors. I have x plus 2 and x minus 3. And now I've found my factor pairs and I can move on. And that's the gist of how to factorize without using, without having an a value. Now, I haven't done an example with an a greater than 1. Because there's a lot of controversy around different methodologies for that. But this is just a very nice way to break down how to factorize trinomials from here. Okay, what we can do though is use the quadratic formula for values greater than a. So let's do that now. Okay, so say for example, we have 3x squared minus 51x plus 17. Okay, what we're going to do is we're going to store these values into our A and our B store into B, and into our C. Okay, just substituting A, B, and C, or saving them into our calculator. And if you want to check that you've saved them correctly, you can just say alpha and 9 has memory on it, and it will just show you a list of all the memory keys that we have. So we've used A, which is 3, B, which is -51, and C, which is 17. And you can see some other stuff down here at the bottom from previous calculations that I've done today. Okay. Once you're happy you've saved all the correct values, we're going to type the formula for the quadratic equation using our A, B, and C into the calculator. So what we're going to do is say negative, and we want a B, so we're going to say alpha and the B button. You'll see there's a little blue B over there. And then we're going to say plus square root, we're going to call B again, B squared, minus 4 alpha A, alpha C over 2 alpha A. So there is my quadratic formula, obviously with just the plus. Okay, and I can just say equals, and it will do all of the substitution in for me. Okay, now what we can do for the next value when we want to put in a minus is we can press this back button so many times, but that will make you cry. So what I'm going to do instead is say left arrow and then second function left arrow, and that takes me right to the front of the calculation. So I can just go behind the plus and change it for a minus. So backspace will delete it, subs in a minus instead, press equals, and there is our second answer. Now that's great for one question, but if you're doing 20 questions, you obviously don't want to type in this formula over and over again. So what you can do is actually store your new A and your B and your C again, and then just go back up to that calculation and press equals, and it will, oh dear, you can see that that's a not real solution. Something is not real there. And so that takes us across to the complex numbers, which we'll deal with in a little bit. So I've actually chosen a bad example. I was hoping I hadn't, but you never know. Let's just change it, the C, and then, sorry, like so, and then see if we can get a new answer. Ah, there we go. You see. So, and then again, we can just go back up to the positives and equal and get a, sorry guys, get a new answer again. Like so. Okay. Any questions here on the quadratic formula? We're all happy. I know I do it really fast, but that's because I have lots of experience, and it's just a matter of practicing, playing around, and getting the hang of it with the calculator as well. So moving on from here, I see there's a question. Okay, great. Well, I'm glad you're happy. Okay, so moving on from here and solving manually for these equations, you actually also have an equation solver on the calculator. So you have a quadratic equation solver and a cubic equation, and then a 2-variable linear equation and a 3-variable linear equation. So if we look at the quad, it's just A, B, and C. So you can just fill in those details again. Let's call it 3 and -51 and 17, like we had in our calculation just now. And there are our two answers. And you can see there's a down arrow telling us that the graph, there's more to it. So the minimum value for this graph is -199, and the x point where that happens is 8.5. So that's just a nice thing to know. Then of course you can also solve cubic equations. And so when we talk about calculus, you can just type in, I'm just going to use an example I know is going to work, which we'll do just now. And equals. Now guys, if you are maths teachers, thanks, Bismarck. I'm glad you like it. If you are maths teachers and you like this, unfortunately, you can't use it if you are a DPE maths teacher because of this equation solving functionality on the calculator. It's no longer allowed. So you need to use a model that's slightly lower than this, and I'll talk about that at the end. But just a heads up that you can only use this calculator in technical maths or the IB syllabus or math literacy. Okay, so here are the various different examples. Let's go to complex numbers. So complex numbers, we're going to press mode and 3 for complex. And complex again is also quite a simple thing to do. So you've got the little x, y's over here, and that means that all of your complex values are given or used or calculated in your rectangular mode. Okay, so in other words, we're using our I values and not our I've forgotten the word for it, the R value, which is the hypotenuse, but there's another fancy tech maths term that we use for it. Okay, so if I press equals, you'll just see that it breaks it up into your real values and into your imaginary values. And if you want the conjugate of this value, you can say math and press 0, and then we just type in whatever we want conjugate for and press equal. I mean, it's quite basic and very simple as well. Polar form, thanks, Sambarasha. Yeah, so you can also convert this into its polar form, and all we do is say second function and r theta, and that will now give us the polar form. So your r is your hypotenuse, and the angle the hypotenuse makes as well. So that's it. And again, if we put it in with your hypotenuse and then your angle, and we wanted to convert it back into rectangular coordinates, we can do it that way as well. So those two buttons, 9 and 8, you can see above it, it says arrow r theta, in other words, 2 polar coordinates, and arrow xy, 2 rectangular coordinates. So that's just the easy way to flip between the two and to get your calculations checked and make sure that they're correct as well. So there's all the steps for that. And of course, the real and imaginary. If you saw on the menu, this just gives you just the real value and just the imaginary value. In other words, what's in front of the eye as well. All right, let's move on to calculus. I just want to show you the integral first because it's just awesome. So we're going to go home. Home just takes you back to normal mode. So we're going to say alpha and open brackets. And I'm just going to make up an example here. So let's say we start at -2 and we go up to 5. And our equation or expression is x cubed plus 7x minus 12. I'm making up stuff here. It's great. And let's say equals. And so we know the area under the curve is 141.75. For right, that is a very good question. Let's go and check. As far as I know, it should be able to do that. So let me check your example. So it's going to be 1 over 6 minus 3i to the power of 6. Oh dear, it did not like that. I honestly, Simbarashi, I don't know because I can't remember what my example was. Okay, so let's just do this and see if it does just powers. No, it doesn't like your power. Okay, so I think it's just a value form of a maximum value that you can do. So your maximum power that you're looking at is 3. Okay, and then from there we can just add in the ones. There you go as well. Okay, so that answers Farai's question. Samarasha, your last example complex, why is it at angle acute? I think you need to just also think about where it is on the graph, but I can't tell you off the top of my head why it's in the wrong place. I'm very sorry. Okay. Okay, so back to calculus now. So we can say alpha and differentiate. So we're going to say, call it 12x squared plus 3x at the point where x is equal to -2. And this just gives us the derivative or the gradient at a point. No problem, Brian. Thanks. Okay, so from here, what I want to now do is show you a very cool example using the table mode. Oh, before I move on to that. So when I set up these workshops and I spent some time and I thought, what cool ways can we do gradients, average gradients? And I looked at using the linear regression function on the calculator. And then I was doing this example on Tuesday morning and I was like, why? It's so long. What is the point of this? All to get to this point where we have b is equal to 3. If you look at the next example, which is exactly the same thing, look how short it is. So I'm not going to show you the other way because I feel like it's actually just a waste of your time. So I'm going to leave that example and I just want to show you that in fact sometimes what you think is a shortcut is actually a really long way around. However, if you have students that mix up the coordinates and they don't substitute them into the wrong place, then I would definitely suggest that they use this methodology with the linear regression, because here they have to type it in as a coordinate pair. So they can't mix up the x's and y's. Well, they could, but if they're typing it in correctly and they're paying attention, they should. And what's nice is they can't mix the two coordinates together. And that might be a good reason to use it. But otherwise, nah, I would just use the shorter route. I mean, we're being ridiculous actually by trying to get to that point. So the next thing that I actually want to show you is we're going to go back to table mode and look at a calculus graph. Okay, so I'm going to draw my graph. It's the same example I used earlier, and it's just because I know that that example works. I took it out of a worksheet that we'd set up for calculus. Okay, so there's my function. I'm going to leave function 2 for now, but I will come back to it. My start and my step as 0 and 1. And you can see straight away at x is equal to 1, y is 0. So we know that x is equal to 1 is a root of this equation. In fact, x minus 1 is now a factor pair. And if I go up here, I can see that my values are just increasing astronomically. So I know that I'm not going to find another 0 in this direction. So I'm going to go back up and look in the other direction. Okay, so even though we started at 0, you can go back up and look in the other direction. You are really unlimited. When I say the table is unlimited, I mean it really is unlimited in that direction. I have done something wrong again. Oh, you know, every time I forget my x. Okay, so there you go. So again, it doesn't, the same point still applies, which is why I only catch it when we go up the other way. So we're still looking in the other direction and we can see it gets very negative and then it starts to increase again. So we just keep looking. There's our second 0, x is equal to minus 6. So we know our next factor is x plus 6. And if we can keep looking, we've got another one at x is equal to minus 8, or our factor is x plus 8. And now if I look in this direction, you can see now suddenly the graph just drops like crazy. Now, what I want to show you from here is we went and took the derivative of this equation, and it's here written for you. And what I'm going to do is I'm actually going to plug that into the second function. So here's my original function. And what I'm going to do is plug in the derivative into this function here. Okay. Right. And leave the same. So if I look again, we can see how fast the gradient is increasing. In other words, it jumped by 186 over 1. And here it's jumping by 239 over 1. So it's an incredibly steep section of the graph. And if I look this direction, here, okay, suddenly I go from positive to a negative, which means that somewhere between -1 and -2 on my x-axis, there is a stationary point. And somewhere between 11 and 6 will be the matching y value for that, okay? If I keep looking, again, my gradient goes from a negative to a positive. So again, I know that somewhere between -7 and -8, I'm going to have a stationary point, and my y value will be somewhere between -1 and 18. So it's just a really nice checking mechanism. to see that we've got all the correct answers. And again, if you look at how positive my gradient is. So if I were to think about drawing this graph, I would have this really positive gradient on the one side, right? It's going like so. Then I have a little bump, then I have a little bump, and then it goes like so. Okay, and so what we've got is we're always looking at this section here, and we never think about going past there. But it's always good to show our students that this graph, when we put that little arrow at the bottom over here, what we're actually saying is that it's just continuing on this line forever and ever. Okay, so it's just my thoughts and observations on calculus and expanding their horizons and what we should be looking at. So I took an example from the Handbook and Study Guide of Kevin Smith, the maths textbook for grade 12. Just as an example to show you doing calculus in various ways. And so the volume of water in a rainwater collection tank, T minutes, that's important, after it starts to empty, is given by the equation VT is equal to blah, 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 where the volume, that's VT, is measured in liters. Determine the initial volume of the water in the tank. So that's our first question. Initial means 0. So in other words, at the time 0, we want to find out how much total we have in our tank. So we can just substitute that 0 and find our answer. You could do it if your mental maths was strong as well. And then the next question is, at what rate is the water in the tank changing? So rate, again, is a hint word. It means derivative. So we have to first simplify this equation, or equation, and multiply it out. Sorry, I see I need to correct that. And have it over here. That's our final equation. Once we've got that, we can take the derivative. Because here, if you were doing AP maths or first year maths, you could do that rule. But we don't do that rule in metric calculus, okay? So the derivative of 100 is 0. The derivative of negative 40t is negative 40 times 1, which is negative 40. And plus 4t squared would be 2t times 4, which is 8t. And now that we have our derivative, I see I need to change that as well. We've got t is 180 seconds, but it's told us in the original question that it's measured in minutes. So we need to change that 180 into minutes by dividing by 60, and that gives us 3. And when I was doing this question on setting it up on Monday or last week, I couldn't understand how it could be decreasing so fast. And then I realized that I should really read the question. And so that's my lesson from today. Read your questions carefully and make sure that your units match the question and the way that it's given to you. Okay, it's always good to highlight units and make sure that we know what we're talking about. So how long will it take for the tank to empty? Well, that's asking you when the volume of the tank will be 0. And again, that's just a simple substitute 0 and solve for t. Now, what I did is I put this into the table mode of the calculator. And you can see that it actually confirms question A's answer, which is the initial volume was 100, and that it takes 5 minutes for that volume to empty. All right, guys. Thank you so much. That is the end of this presentation.